So we are working through exercise 18E and we're working through, in this video, question 13. In the previous video, we went through A, B, and now we're going to go through C, which is asking us to find the local maximum for the graph of V against X, for X is this. So we have restricted the domain. Now, what we're going to do here, before we start talking about the local maximum, what I want to begin by doing is simply graphing what this is going to be. So let's begin by doing that. If I'm going to graph this, what I should first find is what are my x-intercepts. So what are my x-intercepts for this? So let's zoom in and do some maths. If I want to find what my x-intercepts are, I'm going to set my volume equal to 0, and I'm going to factorize this, so I can take out a common factor of 3x squared. And if I do that, I'm going to be left with 5 minus 4, ooh, that's an ugly 4, isn't it? Minus 4x, just like that. Now I'm going to set each of these equal to x, so I'm going to go 3x squared equals 0, or 5 minus 4x equals 0. Now what I'll do is I'll solve each of these. So it's going to be x is equal to 0. And over here it's going to be x is equal to 5 over 4. So that means my x-intercepts are going to be, for this one, 0, 0. And then for this one, it will be 5 over 4, 0. Let's now come and put those on our graph. So I'm going to zoom out here and I'm going to put those points in. So I've got one here at 0, 0. And I have another one, and let's put that one over here at 5 over 4. Let me try that again. It's going to need a bigger bracket. 5 over 4, 0. Perfect. I'm now going to give this a sketch. Now, what we need to take note of is the fact that I have a negative in front of my x cubed term, which means my graph is going to start up here and go down. And I also know that it's going to bounce at this point right here. So it's going to go down like this. Let me try this again. This is the hardest part of the job right here. We're going to go down like that. Then it's going to come back up. It should have more of a, should be more like this. And then it's going to go up like this, and then this is where I might come into a bit of a sketchy mode in order to get this right. It's going to come up, then it's going to come back down like this. This is the ugliest graph I've ever drawn. Okay, and then it's going to be like that, and then it's going to go down. All right, that is pretty ugly, but we'll live with it. All right, now they've told us that they are restricting the domain between 0 and 1.25. Now this is where it's really helpful just to know that 5 over 4 is, if we were to write it another way, this is equal to 1.25, 0. So 5 over 4 is 1.25. So what it is saying is that I'm stopping my graph right here. I'm restricting it at that point, and I'm restricting it at 0 as well. So that means this part of my graph isn't going to exist, and this part of my graph isn't going to exist. It's just this region right here that we care about. I'm finding the local maximum of this region. So what I'm actually doing is I'm finding this right here. This is going to be my local max. This is going to be my local max. So how are we going to find this point right here? Well, what we're going to do is some differentiation. So we've already differentiated it back over here. We found this out. So let's just bring it down. We don't have to go through that process again. I'm going to come over here and I'm going to say this, and I know that that right there is my dv dx. So I'm going to write that in dv capital V over dx. If I want to find what my stationary points are, because my local max is a stationary point. If I want to find what that stationary point is, what I do is I go set that equal to 0, and I'm going to solve for x. So we've got this. So in solving for x, what I'm going to do is set each of these equal to 0. So I'm going to get 6x is equal to 0, and I'm going to get 5 minus 6x is equal to 0. Then I'll solve both of these for x. I'm going to get x equals 0. And I'm going to get x is equal to, this is going to be 5 over 6. All right, so x equals 0. So x equals 0 is one of my stationary points. So that's obviously this point right here. So that right here is a stationary point, but we don't care about it. Just by looking at this, it's quite clear that the one that we're after isn't this one, but rather going to be this one. But we're going to have to prove that this is a local maximum. So this one right here, if we are to be so audacious as to write it in immediately, it's going to be 5 over 6, and then something is going to go here. We don't know yet what that is, but we're getting ahead of ourselves. We need to prove that this right here is a local max. And to do that, what we're going to have to do is, you guessed it, do a bit of a graph. So let's bring this graph over here and put it here. And we're going to prove that 5 over 6 is a local max. So you can't rely on your graph to show this. You have to prove it by using this table thing here. So I'm going to say this is my x. This is going to be dv dx. And then down here, what I'm going to get here is my shape. All right. So I'm going to put 5 over 6 here. I'm going to put, I don't know, let's say a half here, and let's put a 1 here. I know that when it's 5 over 6, it's going to be 0. Now I need to figure out what 1/2 is going to be. So to do that, what I'm going to do, let me zoom in here. Let me come over here. I'm going to go, I have dv dx is going to be equal to, so for this one, let me just move this over a bit. I'm going x is equal to 1 over 2. So that's going to be 6, 1 over 2, 5 minus 6, 1 over 2. That is going to be 3 there. This is going to be 5 minus 3, which is going to be equal to 3. This will be 2. It's going to be equal to 6. 6 is a positive, so it's going to go up. This is going to be flat. If I is now to do the same thing, but now for x equals 1, my dv dx is going to be equal to 6, 1, 5 minus 6, 1, which is going to be 6, negative 1 here, so it's going to be equal to negative 6. So let me put that in. It's going to be negative 6, negative 6. Negative 6 is negative, so it's going to be going down, which therefore means x equals 5 over 6 is a local max. I'm just going to write max and just remind myself, is the question asking, does it say, what does it say? It says a local max, yeah. So that is a local max. Perfect. So we have proved that 5 over 6 is our local max. The question hasn't said find the local max for v. So if you really wanted to be safe in this question, and let's be safe, let's find out what my y value is going to be for this. In order to do that, I'm simply going to take 5 over 6 and put it into my x spot here and my x spot there to find what my v is going to be. Because if we were to think about this, this is v and this is x. So to find what v is, you simply sub it into this right here. So let's do that. Come here. This is going to be v, and let's say v of 5 over 6. What is that going to be? It's going to be 15 5 over 6 squared minus 12 5 over 6 cubed. Now, hopefully, if you were given something like this, you'd be given a calculator. But let's just pretend we're not given a calculator, and let's see if we can figure this out. So we're going to have to do some fancy footwork here, but let's see how we go with it. So I would start by going, all right, let's just leave this first one as it is. The only thing I'm going to do is bring in the square. So I'm going to get this, but I'm not even going to do it yet. Then over here, what I'm going to do is something that you might think is kind of crazy, but I'm going to go, all right, this is going to be 5 over 6 times 5 squared over 6, 5 squared over 6 squared. That, because if I times them, they'll both be cubed, is true. After I've done that now, what I'm going to do is simply rewrite this thing. So what I'm trying to do is just do this as simply as possible without a calculator. All right, now what I'm going to do is I'm going to pop this 5 over 6 out. So I'm going to get 12 times 5 over 6 So because I'm dealing with multiplication, and multiplication is commutative, I can do this. So this is going to become, once I do this will go away, this will become 2. So that means what I'm going to be left with is 15, and let me actually now do this. This 5 squared is going to be 25, 6 squared is going to be 36, and then I'm going to be left with, on this side, 2 times 10. 2 times 5 is 10. And then here, I've also got 25 and 36. So I'm just treating those more or less as terms. So now when I subtract, it's going to be 15, this, minus 10, this. It's going to be, wait for it, 5, because 15 minus 10 is 5. Then I'm going to have 25 over 36. Then I just multiply my numerators. So I'm going to get 125 over 36. And this is going to be centimeters cubed. So that's my volume of the local max. So I could come up here. I could come over here. I could zoom in here. Let me zoom in here. I always imagine this is very disorienting for the viewer here. And this right here is going to be 125 36. Perfect. And just like that, we have solved this thing. Took us some time. I'm going to pause the video here. In the next video, I'll go through some other stuff. But we have now done part C of this question. Hopefully you found that helpful. In the next video, I'll go through part D. I'll see you then.